Welcome back. 3-2, adding, subtracting, and multiplying polynomials. So we're just going to jump right in. We are going to add or subtract the polynomial first. We will notice that the first example is adding. So what we do when we add, we want to stack like terms. So that means under the 5a cubed, the negative 6a cubed, I'm going to put the 5a cubed. Under the 7a or negative 3a squared, I'm going to put 7a squared. The 2a and then the negative 2. So I stack them and I'm going to add them. Okay? So notice I have 4a to the fourth with nothing being added to it. That gives me 4a to the fourth. Negative 6a cubed plus 5a cubed is negative a cubed. Negative 3a squared negative 3a squared plus 7a squared is going to be a positive 4a squared. And then a plus 2a is 3a, and 1 plus negative 2 is negative 1. So let's recap. We kept the exponent the same. We did not change it when we were adding, right? All we did was add the coefficient in front when they were like terms. So negative 6 plus 5, and then kept the exponent. Subtraction is the same way, except minus. So I'm going to put a minus out here. And again, I can only stack like terms. So that means a like term has same variables with same exponents. So both things have to be true. They have to have the same variables raised to the same power. So an a squared and a b squared, we have 3a squared b squared. We have 7ab squared. And then we have negative 9a squared b. All right. And then we're going to subtract. So that is the key. Make sure you are subtracting every time. If you don't subtract, it's not correct. So 2 minus 3 is negative 1. And I do not have to write the 1, so it just becomes negative a squared b squared. 3ab squared minus 7ab squared is negative 4ab squared. And last, negative 5a squared b minus negative 9. Remember, minus and negative is the same thing as positive. So negative 5 plus 9 is positive 4a squared b. So our final answers are at the bottom. We cannot combine anything else because all of our like terms otherwise are combined. When we are adding straight down like that, it combines them. Okay, what about multiplying? Okay, so to multiply, I recommend the box method. If you distribute everything to everything and then combine like terms, and that made sense to you what I just said, by all means, please do it. But I recommend, so we have 2 terms in the first polynomial, and we have 3 terms in the next polynomial. So I'm going to make a 2 by 3 box. So 2 rows, 3 columns. And I'm going to put the 6n squared minus 7 in the 2 rows. And then n squared plus n plus 3 across the top. So when I multiply, I want to multiply coefficients and add exponents. Okay, so 6n squared times n squared. So 6 times 1 is 6. N squared times n squared, I add those exponents to get n to the 4th. I'm going to do that for every box. So think of it as a multiplication table. You know, in a multiplication table, back in 3rd grade when you learned it, maybe you learned it before or after, but you would have to follow your fingers to multiply, right? That's what we're going to do for each of these. All right, so 6n squared times n. Well, this is like n to the 1st power, so that becomes 6n to the 3rd because 2 plus 1 is 3. 6n squared times 3 is 18 because 6 times 3 is 18, n squared. Negative 7 times n squared is just negative 7n squared. Negative 7 times n is negative 7n. And negative 7 times 3 is negative 21. Okay. And if we have any like terms, we want to combine them. Remember, a like term has the same exponent. So when we combine like terms, that means to add. Okay, so for my final answer here, that one's probably not different enough. Let's choose something else. I have 6n to the 4th plus 6n cubed. I have 18n squared plus negative 7n squared. So that's 18 minus 7, which is 11n squared, minus 7n minus 21. Let's practice one more time to make sure we get it, because what happens if I have 3 things being multiplied together? So let's take it back to the first time we ever multiplied 3 things together. So we multiply the first 2 together to get 6, and then multiply that to get 24, right? Let's take that same knowledge and apply it to polynomials. So I have 2 terms by 2 terms. So I'm going to make a 2 by 2 box. And mn is 1 term. 1 is a term. M squared n and negative 1 is the other terms. And I multiply. So m times m squared is m cubed. N times n is n squared. So I'm taking those same rules as above, but I'm only adding like exponents. So adding the exponents together for the m's, adding the exponents together for the n's. Okay, negative mn. Remember, when I multiply by 1 or negative 1, it just it stays the same. Just your sign may change if it's negative 1. All right, so that gives me m cubed n squared minus mn plus m squared n minus 1. So that's 4 terms. Does everybody see how that's 4 terms? 1, 2, 3, and 4. We still have to multiply it by our last term there, the mn squared and the 2. All right, so here I'm going to get m to the 4th, n to the 4th. Here I'm going to get a negative, because positive times negative is negative. M squared n cubed. Here I'm going to get m cubed n cubed. And then negative mn squared. 2m cubed n squared. Minus 2mn plus 2m squared n and minus 2. Whew, that was a long one. So I look for like terms, and it looks like I do not have a single like term. So this entire thing written out is going to be my answer. and it's going to be a lot. So usually we do highest in exponent to lowest, but you know, whatever. I had to make it on 2 rows because it was so much. But there we go. All right. A lot of times, most of the time, you do have like terms. All right, last example. The function v of x equals 48 minus 2x relates to the price v of Carolina's wind chimes to the numbers produced x. The cost of Carolina's materials changes so that her new cost function is c of x equals 4x plus 42. We want to find the new profit statement function. Then we want to find a quantity that maximizes the profit. So we have to use both of these pictures to help us out, okay? So first we need the price. Okay, so notice this function relates to the price times the units sold. Well, the units sold is just x. So if we think about the box here, it's a 1 by 2. And so I get 48x minus 2x squared as my revenue. Okay, so negative 2x squared plus 48x is going to be revenue. All right. And I forgot an 8 there. I love erasers. This is why we do math in something that erases. Okay, and then using the profit statement. So profit equals the revenue, so negative 2x squared plus 48x minus the cost. And the cost function is 4x plus 42. So for this one, it is subtraction. So I'm going to stack them like I did above. I'm going to match the 4x here, match. Now, this part's confusing. There is no constant. So the constant would go by itself with nothing above it. So remember, I moved these, so I'm going to erase them. Okay? So negative 2x has nothing, so it comes on down, negative 2x squared. 48x minus 4x is positive 44x. And then 0 minus 42 is negative 42. So that is my profit function. It says find the new profit function. There it is. All right. And then it says find the quantity that maximizes the profit and calculate the profit. So, but I have Desmos, so I'm going to open Desmos. And I am going to type in that function. So negative 2x squared plus 44x minus 42. To maximize means the maximum height. So what is the maximum height? 11, 200. So now we need to interpret that for our function. Remember, x is the number of wind chimes produced. So x there is 11. So when 11 wind chimes are produced, the profit is the y value, which will be $200. Okay, so what this is saying is that, like, if I make less than 11, like if I make somewhere between 0 and 11, I'm going to make less of a profit. If I make more than 11, I'm also going to make less of a profit because my cost is going to be too high to make that many. Okay, so this is actually real world and figuring things out. All right, we have completed 3-2 notes.